Hello students, myself Dr. Preety Khatri, Assistant Professor IMS Noida. So today we will discuss about the basic terminologies of computer graphics, right? So let's start the topic. The basic terminologies that is called the computer graphics. So what do you know about the computer graphics? If we talk about the computer graphics is made up of by different types of pixels, right? So computer graphics is made up of the data structure, graphic algorithm plus some languages also. Why data structure? Data structure means because data structure is help in the graphics for applying different types of algorithms plus some graphic algorithms that we will discuss further in the next lecture, like Bressenheim algorithm, drawing algorithm, lots of algorithms are there for picture generation and transformation. And the languages in the graphics are high level languages for generation and graphical objects and pictures. So we can say that the computer graphics basically is the branch of computer science which is used to convert the data or visual presentation using the computer. It means the computer graphics involve the picture and graphical objects which are collection of discrete pixels. So we can say that any picture, any image which you can see in the computer or in the television, these are made up of a pixel, right? So next, what is a pixel or pel? So we should know about pixel. Pixel is also known as a pel, right? Pixel is the smallest unit. Smallest unit means, suppose I'm talking about here. Suppose this dot, this dot, that is called a pixel, right? Means on the screen, on the image, the smallest element on the image, that is called a pixel. Suppose this is a image, right? And here in this image, if we produce a dot, right, this is called a pixel. Suppose when we draw a line, this is a line, so this line is formed with the help of pixels. Suppose there are lots of pixels in the line, and when I combine these pixels, there will be a line. So in computer graphics, there are lots of algorithm, lots of methods, lots of procedures are there through which you can produce various images with the help of pixels, right? So without pixels, nothing is possible in the computer graphics, right? So let's start the definition. What is a pixel? Pixel is the smallest unit in digital image or graphic that can be displayed or represented on the digital display device, right? So pixel is the basic logical unit in the digital graphics. It is a basic logical unit, right? So pixels are combined to form a complete image, video, text, and or any visible thing on the computer graphics. So pixels basically in any image, in any video, in any text which we are visible, which we are seeing the things, these are made up of a pixel. So pixel is a smallest element, it is a picture element, right? Without pixel, nothing is impossible in graphics. So the next is, as you can see here, this diagram shows the pixel in this image. When you can see, suppose this is a display area, this is a 0 and this is an x-axis. In this increasing order in the screen, this is a y-axis, right? This is a y-axis. So here on the x-axis at 3 position, and on the x-axis at this position 3, and on the y-axis at this position, it means this pixel value is 3,5, right? The pixel value is 3,5, and this is a 12 cross 8-bit pixel grid. This is a grid, right, shown the rows and column numbers. And this is also a screen where in this the pixels are drawing like in this position and in this position. Here the pixels are drawing in this area and in increasing from this area. And if we talk about this one diagram, here the x-axis value is 3 and y-axis value is 5. So this is the pixel value, right? Here on the left side, rows are numbered from top to bottom. Here rows are numbered from top to bottom, and on the right, these are from the here. These are the top to bottom. This is top to bottom, and this is from bottom to right. So you can draw any type of image where rows are drawn from bottom to top or top to bottom. But the main thing is that we have to find out the value of the pixel. Suppose consider this one pixel right here. So what is the value of this pixel? On the x-axis, the value of the pixel is 2, right? And the value here, and on the y-axis, the value of the pixel is 1. So what will be the value of this pixel? It will be 2 and 1, right? So the next is Now, there is one terminology also came in the mind, that is called a point. If we know about what is a pixel, pixel is the smallest unit in the computer graphics. So what do you mean by a point? Basically, these two terms are related with each other. Sometimes there is a question in the mind that the terminologies are related with each other, or both are the same things, but these are not, both are the same things. These are very much different from each other. Basically, the pixel is the smallest picture element. We have already discussed. This is the smallest element in electronic image. The greater the number of pixels, right? The better will be the quality, better will be the resolution of the image, right? Pixel. What is the difference between pixel and point? The first difference is that the shape of the pixel is square, and the shape of the point is circle. This is the first difference, right? And the shape of the pixel is square, and the shape of the point is circle. And what is a point? Point is a unit of length. Basically point is used to measure the height of a font, right? Basically used in the text graphics also, the point is used, right? In any application, 1 point is equal to, this is a formula, 1 point is equal to 1 by 72 of inch. Means we can say that 1 point is equal to 1 by 72 of inch if we want to convert, if we want to find out the value of a pixel in terms of a inches, right? This is the formula for a point, right? Or if we convert 1 by 72, it will be 0.99 something inches, right? So if we compare with the pixels, the pixel, what is the relation between the pixel and the point? The pixel of 1 point depend on the resolution of the image. Means if the resolution of the image is 72 pixels per inch, then 1 point is equal to 1 pixel, right? What it says means, suppose there is an image, and the image of always image of the resolution is pixels per inch, right? Suppose if we say that the resolution of the image is 72 pixels per inch, it means we can say that 1 point is equal to 1 pixel. At this point, the 1 point is equal to 1 pixel, right? So move further. So there are basic very important things which are comes in the computer graphics. The next thing is called a frame buffer. Frame buffer, we can say that frame buffer is an area which is a temporary buffer, for a temporary buffer where picture definition is stored. You can say that picture definition means, suppose when the picture is drawn in the display image, before going to the display image, the image in the pixels in the form of 0 and 1. The frame buffer consists of the pixel value, and the pixel value can be in the form of 0 and 1. 0 and 1 means, 0 means the pixel intensity is on at that time, right? And 0 means the pixel intensity is off at that time. Means the pixels which we want to show on the display area, it means at that time the pixel value is 1, and the pixel value which do not want to show the display area, at that time the value of the pixel is 0, right? So let's see the definition. A frame buffer is a large contiguous piece of memory, right? At a minimum, there is a one memory bit for each pixel in the raster. This amount of memory is called a bit plane. It means the picture is built up of the frame buffer one bit at a time, right? A memory bit has only two state, as we have already discussed. Therefore, a single bit plane, there are the two colors, black and white, right? You know that a frame buffer is a digital device, right? And the CRT is the analog device. So conversion from the digital representation to analog signal must takes place when information is read from the frame buffer and display on the raster screen. Means, what do you mean by this? Means, suppose on the display area, when we want to, suppose this is your display area, and on the display area when we want to show the image, so those pixel we will see on the image. Suppose like this picture is drawn, this type of picture is drawn on the screen, so only those pixels will be visible, they which have the value 1, and they are fetched from the frame buffer, and those value have 0, they will be remain in the frame buffer, right? So this is the concept of frame buffer. So the next is very important topic, that is called the aliasing and anti-aliasing technique, right? What do you mean by aliasing and anti-aliasing? It says that, suppose when we draw sometimes, suppose these are the pixels, right? And we want to draw some lines with the help of these pixels. Sometime there are some jagged images. When we draw a smooth line with the help of these pixels, the smooth line doesn't come. There will be a jagged image, that is called the anti-aliasing. And the solution of anti-aliasing is solution of aliasing is anti-aliasing, right? Let's see in computer graphics the process by which smooth curves and other lines become jagged. Sometimes the smooth lines become jagged because of the resolution of the graphics or files is not high enough to represent the smooth curve. So in line drawing algorithm, we have seen that all rasterized location do not match with the true line. What do you mean by this? Let's see from this diagram. It will be more clear to you. Aliasing and anti-aliasing technique. What do you mean by this? Suppose this is the display area, right? And these are the pixels we can see here. And when we join these pixels, it will be a like jagged image. The line will be not smooth, right? The aliasing effect can be reduced by adjusting the intensity of the pixel. So there will be a problem when we join these pixels. The image will be like this, like this, like this. There will be sometimes jagged problem is there in the picture. So how to solve this problem? How to solve the problem of aliasing? The solution of the problem is do the anti-aliasing. Anti-aliasing means you have to adjust, you have to increase the intensity of the pixels. That is called an anti-aliasing, right? So see here, in this is called, this is the aliasing, this is aliasing, and this is anti-aliasing. As you can see in this diagram, this is anti-aliasing, right? So what is the difference between aliasing and anti-aliasing? Anti-aliasing basically recover the problem which came in the aliasing. Here you can see the pixels are from each other, right? So when we here see, so the pixels are from a jagged image. So aliasing effect can be minimized by increasing the resolution. The effect can be minimized by adjusting the increased resolution on the raster image. By increasing the resolution, making it twice original one. So line passes through the twice as many columns of the pixel, means we have to, when we increase the resolution of the image, then jagged will be removed. Overall we can say that when the yes, there are lots of methods. Actually, anti-aliasing consists of, there are lots of techniques, lots of methods to reduce this jagged problem, right? But here we will discuss only a small part. This is the main solution to remove the aliasing problem, is that we have to use the we have to increase the resolution of the image, then jagged problem will be removed. So we can say that with anti-aliasing we can smooth the edges and the lessen to the stair step. Stair step means like jagged problem, right? Stair step means like the jagged problem will be removed, right? Now the next, there is a small definition that is called a bitmap or pixmap. Bitmap means the image, bit means two, means the image which is made up of by two values, that is 1 and 0, that is called a bitmap, right? So bitmap is a collection of pixels, or is called a raster image. It is generally used for photo quality of image processing. It is a graphic composed of many pixels like small squares. And pixmap means it's more than two, it's made up of more than two pixels. A pixmap is identified as a spatial mapped array of pixels. A pixmap is known as a bitmap, and it is the smallest unit of bitmap is pixmap. So a pixmap is a creative pixels drawing regularly and cleverly with single pixel as a unit. Means if we compare the bitmap and a pixmap, bitmap is made up of two pixels, 0 and 1, and pixmap is made up of the more than two pixels, right? That is called a pixmap, right? The next is the dot pitch. What is a dot pitch? Dot pitch means dot pitch is very important. Like when we say that the resolution of the image is very important, so the dot pitch terminologies is very important in computer graphics. What do you mean by dot pitch? The dot pitch rating of a monitor tells you just how sharp the display image will be. Dot pitch shows that how sharp the display image will be. Means dot pitch mostly measure in the millimeters, right? Dot pitch measure in the millimeter. It is the smallest number, means smaller number means sharper image, right? In most CRT you measure dot pitch as the distance between holes in the shadow mask. That thing we will discuss from this diagram. It will be more clear to you. Dot pitch concept, like here dot pitch, we can say that the diagonal distance between the pixels in the image. The shorter the diagonal distance between the pixels, more will be resolution, more will be clarity of the image. That is called a dot pitch, right? As you can see here, suppose these are the colors, that is a red color and red color, and right, and the dot pitch is find out in the similar colors, right? Suppose this is a red color and red color, so you can say that Smaller is the distance, more will be the dot pitch. As you can see, red and red color. Smaller will be the distance, more will be the dot pitch, right? Green and green. Smaller will be the distance, more will be the dot pitch, right? Now, the next is, now dot pitch, as you can see here, the dot pitch rating of monitor tell you how sharp the display image will be. Dot pitch means it is measures in millimeters, right? And it is a smaller number means sharper the image. In most CRT, you measure dot pitch as the distance between holes in the shadow mask, right? Mostly, if we can see, the dot pitch are 0.31 millimeter, 0.28, 0.28. There are lots of dot pitch are there. In traditional television, if we talk about them, the dot pitch was very large. It was 0.51, right? But nowadays the dot pitch is very small in that modern computer, right? The next is the resolution. Resolution is very important thing comes in the computer graphics. Resolution means the number of pixels. The more is the number of pixels in the image, better will be the resolution, right? So resolution is the number of pixels in the image. Better will be the number of the, more will be the number of pixels, and better will be the resolution. Resolution means the number of horizontal pixels as well as number of vertical pixels in the horizontal and vertical. Suppose this is a area, so number of horizontal and number of vertical pixels, that is called a resolution. So sharpness of the image is depend on the resolution and the size of the monitor, right? So there are lots of resolution, as you can see, 1280.1023 pixels, 1024 by 768. There are lots of resolution in the computer. Now let's come the aspect ratio. Aspect ratio is basically if we talk about this thing is related to basically the resolution part. Resolution is number of horizontal pixel into number of vertical pixels. So aspect ratio means horizontal and vertical pixel. If you want to find out the ratio of horizontal and vertical pixels, that is called a aspect ratio. So aspect ratio is the ratio of the width of the image to the height of the image. This is the formula. Mostly from this topic, one or two numerical comes in the exam. Like suppose the resolution the image is given, or the pixels are given in the horizontally or vertically, and we have to find the aspect ratio or number of the pixels and so on. So the formula of aspect ratio is number of horizontal pixels as well as upon the number of vertical pixels. For example, let's see a simple example. Suppose given in the question that is the 800 by 600 pixels in the display, so find out the aspect ratio. So these are the, as you can see, the formula is number of horizontal pixels upon number of vertical pixels. So 800 is the number of horizontal pixels and 600 is the number of vertical pixels. So number of horizontal upon number of vertical, and 4:3 is the aspect ratio, right? Let's see another example. Suppose there is a raster system. The resolution is this, given number of horizontal cross vertical pixels. So what is the size of frame buffer? There are the two questions. The first is the size of the frame buffer when they it has the system to store 12 bits per pixel. The formula is 640 into 480 into 12. And why it is divided by 8? Because we have to convert into the we have to this is the but we have to find out the frames of buffer size in the byte, so we have to divide by it. So 450 kilobyte is the answer. So next question, how many storage in bytes is required for the system if 24 bit per pixel is stored? What is the difference between question A and question B? No difference. There is a single difference here. 12 bits per pixel is given, and here 24 pixel is given. So instead of 12, you have to change here, it will be 24, and the answer will be come, right? So next comes is the refresh rate. Refresh rate means how much time is taken by the computer to refresh, right? That is called a refresh rate. And refresh rate normally measured in hertz. Suppose we can say that monitor refresh rate is 75 hertz, means the 75 hertz means that screen is going to be refreshed 75 times per second. That is called a refresh rates, right? In the if we talk about the older television, the refresh rate was very like you can say that it will be it take very large time to refresh. But if we talk about the LCDs, LEDs, normal television, modern television, so refresh rate is very, there is very nominal, very less, right? Now it's a very simple talk about the interactive and passive graphics. Interactive graphics means through which we can control, right? That is called a interactive graphics, right? And what is that is called interactive graphics. And what is passive graphics? Passive graphic means the user has no control. Means, for example, if we talk about like computer games, these are the interactive ones, right? The user has a control. You can give a command, user can pause, user can start the game, right? That is called interactive graphics. Nowadays, like televisions which are very much interactive, user has control, these are the interactive graphics. And non-interactive means like those screens on which the user has no control, that is called a non-interactive graphics, right? For example, the movie in the cinema hall and all. Now the next is the characteristics of computer graphics. There are lots of characteristics of computer graphics. It is very interactive, user friendly. These are very simple characteristics. Motion dynamics, yes, motion dynamics means it allow the user to move the objects. It provide update dynamic facility, right? Dynamic facility means we can change, we can apply the transformation, various transformation techniques like rotation, scaling, and various types of operation. And this is called a dynamic facility. And animation technique, right? The user has the ability to show the moving picture, right? The next is the component of computer graphics. Yes, this is important. The component of computer graphics. In computer there are lots of components. If we talk about, let's see this diagram, there are various components. This is called a frame buffer. This is a frame buffer, right? This is frame buffer, and this is a display controller, this is video controller, and this is the keyboard. This is our display area. And when we give the input through the keyboard or the mouse to the display controller, if we see here, the display controller and between the video controller there is a frame buffer, right? From the display controller command given to the frame buffer, as you can see, video controller is the intermediate between the frame buffer and the display device, right? Suppose in the monitor screen we want to display like this shape like hut, right? So those pixels will be displayed which have a value 1, and the which have value 0, there it will be not displayed. Like if I can draw here, as you can see, the pixels which are in 1 1 1 1, these will be displayed. And here it has 0 0 0 0, so this area, these are 0 0 0 0, so this will not be displayed. As you can see here, 0 0 0 0 in this area, so this will not be displayed. And like this, so 1 1 1 1 1 1, this area will be displayed, right? So from this diagram, frame buffer concept will be more clear to you, right? Frame buffer will store the picture definition in the form of 0 and 1. Only the values which are 1, that will be displayed on the display screen. And video controller is a communication between the frame buffer and the television screen, and display controller basically control these devices, right? So as you can see here, the digital monitor frame buffer, digital memory buffer, right? Memory buffer means we can say that it's a frame buffer which store the value in the form of 0 and 1. TV monitor is there, display controller we have already discussed. Now let's come, these are the applications of computer graphics, right? So that means the area where the computer graphics is used, it's very general thing. Like if we talk about the computer arts, right? In the computer graphics can be used for the computer art, for animation, for paint packaging, in CAD designing. Yes, it's very important. In CAD designing, for designing building, automobile, lots of things we can use the graphics. For presentation, like in industry, for businesses we can use the graphics. For entertainment, like in movie industry, in game industry, in animation, we can use the graphics. In education nowadays, graphics is more important for all of us, right? And training, for training purposes, right? For training, for creating training modules. The next is visualization, for visualizing the thing, right? To check the study and behavior of processes around us. So visualization is very important for us. And for image processing, yes, image processing is very important, because there are lots of images which are required for editing the various images. So image processing is very important, and the main application of the computer graphics. And yes, the machine drawing, yes, the graphics is used for designing and modifying various types of machines, right? And GUI, yes, GUI is a graphical user interface. GUI means like different types of icons, pop-ups, right? So from this thing, I thank you all. Thanks to you. So these all are the basic terminologies which are related to the computer graphics.